Hello dear students. Now we'll see one example on fundamental torque equation. In this example, a drive parameters are given. So here J is given, it is 10 kg meter square. Motor torque equation is given, it is 100 minus 0.1 N Newton meter. Passive torque equation is given, it is TL equal to 0.05 N Newton meter. Now passive torque means passive load doesn't change its sign with direction of rotation. So generally the load torques which are active, they change their sign with direction of rotation. This is a passive load torque. Now in this motor torque equation there is N here. This N means speed in RPM. So this torque is function of speed, like that it is given. And we can easily see that this is equation of straight line, isn't it? So in the form of slope point form, y is equal to mx plus c. This is y parameter, x parameter, torque and speed, mx. So this is m, slope of the characteristic, it is negative slope, and this is plus c. C is y intercept. That means this is a straight line passing through plus 100 point on y-axis, this which is having slightly or small negative slope. Similarly, this load torque characteristic, it is in the similar form, but it is y equal to mx only. C, y intercept is 0. This is passing through origin, and it is this slope, positive slope into x parameter n. So we have to calculate the speeds. Actually it is given initially the drive is operating in steady state. Now it is to be reversed. For this, motor characteristic is changed to T equal to minus 100 minus 0.01 N. See the difference. The y-intercept here previously in motoring condition it was plus 100. This is the same parameter here, but the slope is now, the y-intercept point is now minus 100. So motor characteristic is changed for reversal of speed. Calculate the equilibrium speed in forward and reverse operation. So just to show you here, this is a torque speed plane. So this is torque, and in this case it is speed in RPM. Now if I plot the equations, the motor torque equation, 100 minus 0.1, 100 is y-intercept, so this is 100, and this is a straight line passing through 100 having a small negative slope. Okay, so this slope is minus 0.1. So if you calculate the slope of this line here, it will be minus 0.1. Then the load torque, it is passing through origin. So let's say it is like this. This line will be passing through origin. So this is the operating point A in motoring quadrant. It is asked to calculate equilibrium speed. Then motor is reversed. For that, the you can say characteristic is changed to minus 100 and minus 0.01 N. So that means it is passing through minus 100. Still having negative slope, slightly negative slope. And this characteristic doesn't change. So this will be the another operating point. So this is load torque characteristic. This is motor torque characteristic. Now we know that this is the steady state point. This is also steady state point. So at steady state, we know that T minus TL equals to 0, or T minus TL equals to 0, or T equals to TL, like that. So this is the condition for steady state. Now in forward direction, or operation, we can write, we can substitute here T. Equation of T is 100 minus 0.1 n minus 0.05 n equals to 0. Now we can solve this for n. So we get 666.7 RPM, and this is the steady state speed in forward direction. It comes out to be positive. Now we have to calculate speed at this point. So let's say this is NF and this is NR. So this is nothing but NF, speed in forward direction. Now the another situation in reverse operation. The characteristic of motor is changed to minus 100 minus 0.1 n. The torque remains the same. Equals to 0. Now when we solve this, we get again value of n minus 666.7 RPM, which is nothing but the speed in reverse. So this is how we can solve the numerical.